when the differentiation of a function does not exist, when you have a cusp, if you have a function like x to the power 2/3. So here, when you draw the graph of the function, you will see there is a cusp at 0. And if suppose your function is x minus 2 to the power 2/3, so then you'll see the cusp at x equals to 2, because that you cannot find the slope at this point. Like before this, the slope is continuously decreasing, and after the slope suddenly starts increasing. So here, if you draw the tangent like this, here tangent is like this. So for in here, the tangent is negative, on the right hand side, tangent is positive. So you cannot determine what is the value of tangent at this point. Differentiation does not exist. Vertical tangent. Right, so when do we get a vertical tangent? It's like suppose if you have a function like 1 over x plus 2, like when you have a hyperbolic function. So when you find the differentiation of this function, it will get negative 2 over x plus 2 whole square. See, when you plug in x as 2, x as negative 2, so there you'll see a 1 over 0, that is infinity. So your slope becomes infinite, like 1 over 0. That is, you'll get a vertical tangent, like your differentiation does not exist. This also happens when you have a function to the power 1/3. Third case, when you have a discontinuity in the function, then also differentiation does not exist. So this function is, when you plug in a negative value, you will get -1 as answer. When you plug in a positive value, you'll get a +1 as an answer. It would be like this. So if the function suddenly jumps, then at this point, like x equals to 0, you cannot differentiate the function. At other points, it is differentiable. Function is not changing, so the differentiation would be 0. The fourth condition, when you get a corner. Corner means whenever there is a sharp turn, the turn is not smooth. When there's a corner, or here also you can, when you see a corner, so whenever there is a corner, the differentiation does not exist. Because if you look at to the left and the right side, the slope direction is changing. Here the slope would be positive because it is going up, and here the function is going down, so its slope would be negative. So negative slope here, positive slope here. So when you go into the neighborhood of this point, corner point, you will see a positive and negative slope same time. So you cannot determine what will be the slope at that point. So the differentiation does not exist here.